In this video, we're going to go over how to multiply rational expressions. So in order to multiply rational expressions, you're going to start off by factoring the numerator and denominator of both fractions. So basically, you're just going to factor everything. And then you're going to cancel any common factors and then multiply the numerators together and multiply the denominators together. So you'll see that this is very similar to what you do when you are multiplying actual fractions with numbers in them. So let's start off with this example. So my strategy here is just to go ahead and factor everything. So I want you to be able to see my work. So what I'm going to do is I'm going to number the numerators and denominators. And this is not something that you have to do, but I'm just doing this so that you can see what it is that I'm factoring. So I'm just going to number everything and then color code. So let's look at that first numerator, x squared minus 4x plus 3. So I know that in order to factor this, I need two factors of 3 that are going to add up to negative 4. Well, the factors of 3 are 1 and 3, and we know that since 3 is positive, I need them to have the same sign. Since 4 is negative, I'm going to go ahead and make both of these negative, so that's going to give me the factors x minus 1 times x minus 3. So this is the fully factored form of that first numerator. Now let's go to that first denominator. So we have 2x plus 2. So remember, we have lots of different factoring methods. If it's not a trinomial, a good thing to check for is a GCF. These two terms do have a GCF, and the GCF is 2. So I'm going to go ahead and factor that out. So I'm going to divide both of these terms by 2, and that's going to give me 2 times x plus 1. Okay, so that's the factored form of the first denominator. So the next numerator, the second numerator, is just 4, and it may seem silly why I'm factoring like this, but I'm just going to write this as the product 2 times 2, okay? And now let's finally do the last denominator. So that's x squared plus 2x minus 15. Okay, so we need two factors of negative 15 that are going to add up to 2. Since 15 is negative, I need a positive and a negative factor. And I know that since 2 is positive, I'm going to make my bigger factor positive. So the correct combination is going to be 3 and 5. And if I make the 3 negative, I'm going to get negative 3 plus 5, which is 2. So that means it's factors to x minus 3 times x plus 5. So let's go ahead now and rewrite this multiplication in fully factored form. So the first numerator is now going to become x minus 1 times x minus 3. The first denominator is going to become 2 times x plus 1. And then we're going to multiply that by the second numerator, which is 2 times 2. And then that's over, let's see what we have. We have x minus 3 times x plus 5. So now what we're going to do is we're going to cancel common factors, but when we cancel common factors, we can only cancel them if they're on opposite sides of the fraction. So like I can cancel this x minus 3 and this x minus 3, and I can cancel this 2 and 2. And let's see, we don't have anything else that cancels, so our answer is now going to be 2 times x minus 1 over x plus 1 times x plus 5. So depending on what you're working on, you may be able to leave your answer in this form. This is factored form. Or in some answer choices, it may expect you to go ahead and multiply these together. So for example, that we do the 2 times x minus 1, so we get 2x minus 2 in our numerator. In the denominator, when you multiply x plus 1 times x plus 5, you get x squared plus 6x plus 5, right? You can just use FOIL to do that. So it really depends on what form they're giving you in your answer choices. You may be able to leave your answer in factored form, or you may have to go ahead and multiply everything out. So let's try another example. Let's try this one. So once again, I'm going to use the same strategy. I'm going to number my numerators and my denominators so you can see what I'm factoring. So here, let's call this 3 and let's call this 4. Okay, so number 1, we have x squared minus x minus 12. So remember that middle term is actually a negative 1, so I need two factors of negative 12 that are going to add to negative 1, so that'll be 3 and negative 4. So that's going to give me x plus 3 times x minus 4. That first denominator, 2x minus 1, it doesn't factor, so I'm just going to leave it like that. Now let's go ahead and factor the next numerator. So we have 2x squared plus 7x minus 4. So here I have a situation where my a is not equal to 1. So remember, I have to do a times c, right? 2 times negative 4, so that gives me negative 8. I need two factors of negative 8 that are going to add up to positive 7. So the factors that are going to work are going to be negative 1 and positive 8. So I have to use factoring by grouping here. So I have 2x squared minus 1x plus 8x minus 4. So let's put these terms into two groups. So I have 2x squared minus 1x plus, and then we have 8x minus 4. Okay, so now I'm going to factor out the GCF of each group. So here I factor out an x, so I have 2x squared over x minus 1x over x plus, and then from the second group I have 4, and then I'm going to factor that out. So I have 8x over 4 minus 4 over 4. So if I reduce this now, I'm going to get x times 2x minus 1 plus 4 times 2x minus 1. And so when I write that in fully factored form, I have 2x minus 1 times x plus 4. Okay, so now let's finally factor the last denominator. Okay, so that 2x squared plus 6x. Notice it's not a trinomial, so remember I told you to check for a GCF when you have something like this. The GCF of these two terms is 2x, so if I factor out the 2x, I have 2x squared over 2x plus 6x over 2x. So when I do that, I have 2x times, 2x squared over 2x is just x, and then plus 6x over 2x is 3, so that's the factored form there. So now let's go ahead and put everything back in our factored form. So my first numerator is x plus 3 times x minus 4. Okay, and then that's over my first denominator, which we didn't factor. That's just 2x minus 1. And then times my second numerator, which is, let's see, we have it here, 2x minus 1 times x plus 4. And then my second denominator, which is 2x times x plus 3. Now let's go ahead and cancel our common factors. So you see here I have a 2x minus 1 and a 2x minus 1 that cancel. X plus 3 and x plus 3 will cancel. So in the numerator, all I have is x minus 4, x plus 4. Denominator, I just have 2x. So if I write that out, I have x minus 4 times x plus 4, and then that's all over 2x. So if your answers are all in factored form, this is the correct answer. If they want you to multiply the factors together, the numerator will multiply to equal x squared minus 16. You can do that using FOIL, or you can recognize that that is the difference of squares, and that will be over 2x. Okay, so either of these is the correct answer. So now you can go ahead and pause the video and try doing this example on your own. So here you see I've gone through and factored everything. So this number 1 factors into 2x plus 1 times x minus 3. 2 doesn't factor because x plus 2 is just going to stay as itself. 3 factors into x plus 2 times x plus 2, and then 4 factors into x minus 3. It's just going to stay as it is. Here I've written out the equation, or sorry, the original expression with all the fully factored forms, and you can see x minus 3 times x minus 3 will cancel, x plus 2 and x plus 2 will cancel, and all we're left in the numerator is 2x plus 1 times x plus 2. So basically this is like 2x plus 1 times x plus 2 over 1, but we don't need to write it as a fraction. It's just going to look like this in factored form, and if you multiply these together using FOIL, you get 2x squared plus 5x plus 2.